Hi everyone, my name is Giulia Bronzi and I'm a senior at Wellesley College. Today I will be telling you about our project on predicting the outcome of dogs at the Austin Animal Center. Unfortunately, my co-authors Hannah, Willa, and Nikki couldn't join me today, but we're very grateful to be presenting our work to you. So some background on the project and the dataset we used. This was the result of a final project for an applied statistics course. It was fairly open-ended, and we found this dataset from the shelter on Kaggle, and we picked it because we thought it could lead to an interesting project and some interesting results. The Austin Animal Center is the largest no-kill shelter in the United States, and the dataset has data on all the animals brought to the shelter from 2013 to present day. The dataset includes information on the animal's intake at the shelter and the animal's final outcome, and it has variables such as the type of animal, the health and age of the animal, and how long the animal has been at the shelter for. There is data on several species, but we decided to just focus on dog. We wanted to investigate how variables such as breed, size, sex, and age can be used to predict the outcome of dogs at the shelter, and we thought that such results could be used by the shelter to help inform their decisions upon a dog's intake, including things like how long a dog is expected to remain at the shelter, and how likely it is that the dog will be adopted, and deliberate choices that the shelter can make to help increase the likelihood of adoption. Going into this project, we hypothesized that purebreds and younger dogs would be adopted more than mutts and older dogs. For the data cleaning process, the first thing we had to do was subset the data to only look at dogs, and then there were several variables that we weren't interested in using, so we just ignored those. We also had to clean up several variables to simplify the prediction process. The longest being the variable for size. Going into this project, we didn't realize how many different dog breeds there are. We were thinking that the dataset would have a couple hundred, but it ended up having around several thousand different dog breeds. There was a lot of different mixes, and it got really complicated. So to simplify the prediction process, we used the dog's breed to create a variable for the dog size. And we did this by merging our data set with one that sorts dog breeds into different sizes. And then for some of the mixed breeds, we had to manually enter the dog's approximate size. In the end, we had 5 sizes, and it was toy, small, medium, large, and giant. We also had to modify the outcome type variable. Initially, this had several different categories, but we grouped them into whether the dog was adopted, had died, was returned to its owner, was transferred to another shelter, and the other categories were missing, disposed, and euthanized, which we grouped into died. Going into this, we knew that age would be an important predictor, but there wasn't a variable for age upon outcome, so we used the columns for age upon intake, which is when the dog was first brought to the shelter, and how long the dog was in the shelter for to calculate the age upon outcome. We also used an existing variable to create 2 separate variables telling us whether the dog was spayed or neutered and the sex of the dog. Lastly, we modified the intake condition variable to tell us whether the dog had normal health conditions when brought to the shelter or non-normal health conditions. At first, this variable had the category sick, elderly, feral, injured, or pregnant, but we grouped these into one category representing not normal. Once we cleaned up the data set, we split the data into 2 subsets. So we had a training set with around 35,000 units, and then a testing set with around 10,000 units. And the end goal for our models were to accurately predict whether a dog will be adopted, returned to its owner, transferred to another shelter, or die at the shelter. We created a full and a reduced model. The full model uses the predictors age, size, sex, whether the dog is spayed or neutered, the time spent in the shelter, and the intake condition. And then for the reduced model, we only use the size, sex, and intake condition of the dog. So here are 2 tables showing the accuracy of our model. The full model was predicting at 66.9% accuracy, and the reduced model, which again was only looking at size, sex, and intake condition, was predicting at 44.5% accuracy. We attribute this drop in accuracy to the absence of an age variable. As you can see, the reduced model underpredicts the number of died and returned outcomes, and the average age of those 2 categories is higher than the others, which is why it's less accurate. The full model was predicting significantly higher than the reduced model, and because of this, we weren't too worried about overfitting. So this was our final prediction tree, and it's based on the full model. Just starting from the top of the tree here, we can see that the age upon outcome is the most important predictor, which fits with our hypothesis that overall age has an effect on outcome. And we can see that within the dogs that have a younger age upon outcome, so this half, those that spent longer in the shelter have a higher proportion of adoption compared to the other outcomes. So these three. For younger dogs that spend less time in the shelter, we can see that the highest proportion of transfers, and this correlates to dogs that are only a couple of months old. And we believe this means that the shelter might send puppies to other shelters that deal more with younger dogs, or maybe sent to a vet until they are old enough to be adopted. For dogs that were older upon outcome, and intake condition has a high predictive power, but otherwise, when intake condition is normal, adoption preferences seem consistent with the other predictions for other dogs. We can see that the plot with the highest proportion of deaths is this last one here. And we can see that the plot, which correlates to dogs with a non-normal intake condition. And it makes sense that if the dog was sick or injured, it would have a higher chance of dying in the shelter and a lower chance of being adopted. In the plots above the red bar, we can see the comparisons for in adoptions for male versus female dogs. There's a slight difference, but it isn't huge. So it probably means that the dog's sex doesn't affect its chance of being adopted very much. So we can see that male dogs have a probability of around 70%, while female dogs have a probability of around 80% and 70%, depending on how long they've been in the shelter for. On the plots above the yellow bar here, we can see the difference in adoption rates for larger dogs versus smaller dogs. It also isn't huge, but small dogs and toy-sized dogs are adopted at slightly higher rates. So we're looking at 50% and 30% for medium, large, and giant dogs versus 55% and 40% for small and toy dogs. On the plots above the green bar here, we can see that the dogs that are older have a normal intake condition and spend less than 4 days in the shelter are returned to owner much more than the other outcome options. This indicates that dogs fitting these categories maybe had chips and had gone missing, but were reunited with their owner shortly after being brought to the shelter. Overall, dogs that are younger upon intake and smaller in size have a higher likelihood of getting adopted. And when the dog's intake condition is not normal, there is a smaller probability of adoption and a higher probability of death. So in the end, I think we're pretty pleased with our model. We think these results could be used by the shelter to help determine which dogs may have a hard time getting adopted, which will hopefully lead them to make decisions on helping the dogs have a better chance at being adopted. We also believe that by predicting the dog's outcome at the initial intake, the shelter would be able to save time and resources. One ethical concern that came up was that by predicting at intake that a dog is likely to die in the shelter, they may be less motivated in trying to tend to the dog's needs. Hopefully this wouldn't happen, but it is something that we thought people needed to be aware of. Our model could also be affected by biases towards less favored breeds or dog sizes, so it would be important for shelters to think about these biases while using the model. In the future, our model could also be used to investigate other outcome variables, and it would be interesting to make models for other animals and shelters. Thank you so much for listening. I hope you enjoyed. We also just want to thank our sponsor, Professor Patnaik, for all her help.